Okay, in this section 1-5, we're talking about the graphs of functions, and there are really two things that we want to be able to accomplish from this lesson. Number one, we want to be able to look at the graph and determine over which intervals the graph is increasing, decreasing, or constant. And the second thing that we want to be able to determine is, by looking at a graph, determine the relative maximum and the relative minimum on the graph. All right, so let's talk about increasing and decreasing first. Okay, so when you're looking at the graph of a function, as far as moving from the left to the right, then if the graph itself, like on this interval from here to here, as you move from left to right, then the graph itself is going down from left to right. So we would consider that as decreasing over that interval. Okay? In this next interval that we're looking at from here to here, the graph is flat. It's not increasing and it's not decreasing. We would say it was constant over this interval. And then the third interval, then it's going up. So we consider that as increasing. Okay, so if you've got the graph, it's very quick and easy to get a visual look at the graph and determine whether it's increasing, decreasing, or constant. Okay, so from this interval, -2 to 0, decreasing. From 0 to 2, constant. From 2 to 4, increasing. All right? And below that, we have the actual definitions of increasing, decreasing, and constant. So let's kind of work through that so you can get an idea of the mathematical wording in the definitions. And really, that's kind of one of the goals that we need to try to move toward, is you need to be able to read mathematical language and interpret it, right? So let's go through this now and take a look, okay? And, you know, before we even look at it, what I just told you right here, if it's going down, it's decreasing. If it's flat, it's constant. If it's going up, it's increasing. That's exactly what these three definitions say. But if you just look at this, you might say, oh man, this is hard. What's it saying? Okay? That's all it's saying. So we have to be able to decipher mathematical speak to get a good understanding of what is trying to be relayed to you. So let's look at these. So it says a function f, all right, so f is the function. It's increasing on an interval, okay, when, okay, for any x sub 1 and x sub 2 in the interval, right, okay, that if the x sub 1 is less than x sub 2, okay, so in other words, the first point that we pick on the graph, right, is less than, okay, the second point that we pick on the graph. That implies that f of that first point is also less than f of the second point. So in other words, for example, like right here on this graph that we looked at earlier. So if I pick 2 as my f1, as my x1, and 4 as my x2, then that implies that f of 2, because look, because 2 is less than 4, right? Then that implies that f of 2 is also less than f of 4. And let's see if it is. Well, when we plug in 2 to the function, what do we get? 1. And when we plug in 4, we get 4. So is 1 less than 4? Yes. All right, so if that's true for any x sub 1 and x sub 2 in the interval, okay, if the one is less than the other, then the evaluation in the function of the one has to be also less than the other. Okay, so this is mathematical speak for what we talked about visually right here, increasing, what it means. Okay, so like I say, if you're able to decipher through the mathematical language and symbolism, okay, you're able to interpret what it says, and what it says is just simply, if it's going up, it's increasing, right? Okay, so decreasing on the interval with for any x1 and x2 in the interval, all right, if the x is less than x sub 2, then f of x sub 1 is greater than f of x sub 2. So it's kind of the opposite for decreasing. So like for here, if we look on the decreasing interval on the graph that we have, so here's my x sub 1, -2, my x sub 2 is 0. So x sub 1 is less than x sub 2, but when I plug it into the function, what happens? If I plug in -2, I get 4. If I plug in 0, I get 1. All right? So even though x sub 1, 2 is less than 0, the f of the x's, 4, is actually greater than 1. All right, so if that happens for all of the elements in that interval, then you know that the function is decreasing. All right, so constant, what does that mean? If for any x sub 1 and x sub 2 in the interval, f of x sub 1 equals f of x sub 2. So when you plug these two into the function, you get the same thing every time. And it doesn't matter which one is greater than or less than, you should get the same thing when you evaluate it. For example, let's look at the constant interval here. So we have 0 and we have 2. Well, when I put in 0, what do I get? 1. When I put in 2, what do I get? 1. 1 equals to 1. If that's the case, then you know the function is constant. So that's the formal mathematical definitions of increasing, decreasing, and constant when you are looking at a function, right? And so the type of problems that we're going to be looking at, the directions are going to say determine the open intervals on which each function is increasing, decreasing, or constant. Okay, so they've given us a graph. Okay, they could have given us an equation. If they give us, well, they actually give us the equation and the graph, but they could have given us one and not the other. Like, for example, if they give us the graph, all we got to do is look on the graph and see what the intervals are and write them out. If they only give us the equation, then we would graph it first and then use the graph to make our determination of increasing, decreasing, or constant. So let's look at the first one and see how it would work. Okay, on problem A. When I'm looking at this graph, okay, and let's start from left to right. Okay, so first of all, when I start from the left and go to the right, I see that the function begins by increasing. It begins by increasing. Now, once we get right here to 0, okay, it becomes flat only at that point, right? But then it continues to increase again. All right, so right here at this point at 0, remember, even though it does go perfectly flat at 0, it does not remain there for any other point. In other words, the only point where the y value is 0 is at 0. Once I step out here, it's already above 0 again, right? So since it doesn't remain at 0 over any interval, there's no constant interval here, all right? So keep that in mind. So actually, if we analyze this all the way through, it's increasing over the entire graph, all right? So over the entire domain, this function is increasing. And so what we're going to write for as an answer is that it's increasing, okay, increasing, and then we'll write the interval over which it's increasing. Well, it's increasing from negative, whoops, it's increasing from negative infinity to positive infinity. All right? All that one does is increase, doesn't do anything else. Increasing from negative infinity to positive infinity. Okay, if we slide over and take a look at the next one now, then on this particular one, if we start reading it from the left, we see that it begins by increasing, so we'll write that out first. Okay, we know it's increasing. Now let's see if we can figure out over what interval this particular one is increasing. All right, so it starts out at increasing from negative infinity, so I'll go ahead and write that out. Okay, now let's see where it stops increasing. Okay, it does continue to increase until we get to this point at negative 1, 2. So they've actually given us the point where it changes direction. So at negative 1, 2, it actually stops and then changes direction. Excuse me. And so it's increasing over the interval from negative x to negative 1. Increasing over the interval from negative x to negative 1. Okay, so at negative 1 now, it begins to start decreasing. And so now, okay, we know this thing is decreasing. And where does it start decreasing? Well, it starts decreasing at -1. Okay? Starts decreasing at -1. And it decreases all the way to here, okay, which is at +1. It's at +1. Okay? Now, remember, when you're writing out the values where the function begins to increase or decrease, make sure that you're writing out the x values of those points at the function, not the y values, right? Not the y values. It's the x values that you write out the intervals for increasing and decreasing. Okay, so keep that in mind. So now, once we get to +1, what happens? Well, it changes direction again, and it changes direction to increasing again. So it goes back to increasing over the interval from 1 to positive infinity. All right? And if we wanted to, we could actually write this out next to this one if you wanted to and use it on the same line since those are both increasing. Okay? For the last one, again, analyzing from left to right, it starts out by increasing. All right, it's increasing. Oops. And it starts increasing at -infinity and continues to increase all the way to 0. Now, at 0, what happens? Well, at 0, it goes flat, so that would be constant. At 0, it goes flat, so that's constant from 0 to which point? To 2. Remember, you're looking at the x values when you're writing out the intervals. So it's constant from 0 to 2. And at 2, it begins now to decrease. All right, so it's decreasing from 2 all the way to positive infinity. All right, so decreasing from 2 to positive infinity. Okay, so those are some examples of how to write out the intervals when you're looking at the graph. And that's one type of problem that you'll be expected to do. And here's the other. Okay, so the next thing we're going to talk about is relative minimum and maximum values. And so the point at which the function changes its increasing, decreasing, or constant behavior, okay, those are the points that will help you determine the relative minimum or the relative maximum values of the function. So relative mins and maxes occur at the point where the increasing or decreasing or constant behavior begins or changes. All right? Because like if it's increasing, but it never changes from increasing, then there is no relative maximum. Okay? The place where it changes from increasing to something else, that's where your relative max or min is going to occur. All right? Let's see. So we have the formal definitions. More math speak. Let's read through and interpret what it means. Okay, it says a function value, f of a, is called a relative minimum of f when there exists an interval from x1 to x2 that contains a, the point you're evaluating, such that this condition applies. When the x is between the x1 and x2 on the interval, okay, then that applies that f of a, okay, is less than or equal to f of x. Okay, so let's think about what that means for just a minute. Okay, so what that means is that in order to be a relative minimum, okay, then this condition has to apply. Okay, this condition has to apply. Okay, if you've got any x that's on that interval, right? Okay, on that interval, then what that means is f of a, okay, when you plug in a and evaluate it, it's got to be less than or equal to f of x, anything that you can plug into the function at that interval, right? And so what that means is what you're picking as your relative minimum, what you plug in, the x value you plug in there and evaluate, it's got to yield less than or equal to any other output that you can put in for that interval. Otherwise, it can't be the minimum of the function. And likewise, for a relative maximum, it's just kind of reversed. Okay? On the interval, x1 to x2, that contains a such that for any x that you pick on that interval, it implies that f of a has got to be greater than or equal to any other value you can put in at that interval. So basically what that means is whatever you're picking for your max has got to be either greater than or equal to anything else you can put in for the function at that value. Otherwise, it's not a maximum. And minimum likewise. It's got to be the lowest, greater than or equal to the lowest value that you can put in for that interval to the function. All right? And so here's kind of some examples of what it would look like on the graph. So like if this is your interval right here, this would be a relative minimum. All right? That's the lowest point on the graph. Relative minimum, lowest point on the graph. Relative maximum, that's the highest point on the graph, say for this interval from here to here. Relative minimum, right? So for this interval, this is the lowest. Relative maximum, for this interval, it's the highest, and so on. All right? So there you go. And a lot of times a relative maximum or minimum could depend on what interval you're looking at. So like for example, if I was looking at the interval from here to here, then this would be the only relative maximum. This wouldn't be a maximum. It's a maximum for the smaller interval, but it wouldn't be a maximum for the bigger interval. So keep that in mind too when you guys are looking at this. All right, so let's take a look here. We have a couple of practice problems we want to look at. It says using your graphing utility to approximate the relative minimum and relative maximum of the function given by this. F of x equals to negative x to the third plus x. All right? So here is my graph. Okay, so they've given me a graph. Okay, so what we're going to have to do now is on the practice problems, okay, they're not going to give you the graph. They're just going to give you the equation, right? So here's what we're going to have to do. We're going to have to be able to take the equation and graph it. Now, if we were in class, I would hand you a graphing calculator, no problem. Graph it, do it, okay? But since you're at home, you're going to have to rely on your own means to graph this thing. And what I would suggest is the calculator I've been suggesting to you all along, and that's the Desmos has a good calculator. It's called Desmos. And so if you go in and you download that, it's free for your phone. Pull it up. There we go. Graphing calculator right there. That's all you need. And so, okay. So again, if you download that Desmos calculator, then you will be able to go in and you click here and then you just type the equation in, exactly what it is. So it would be y equals negative x to the third power. Now, to get squared, you can type a squared, but if you want higher than squared, you got to type a to the b power. It'll raise it up to that exponent, and you'll just type a 3 in there. Don't forget to arrow back out, or you will keep typing exponents on there, so keep that in mind. And then we can type the rest of it in there. It's plus, oh, I hit the wrong thing, plus what? Plus x. All right, and then it graphs it for you. You don't even have to press enter or anything like that. Okay, so now, here's what we want to find. Okay, so we want to find the relative minimum and the relative maximum of the function. So let's start off with the relative minimum. All right, let's see if we can find the coordinates of the relative minimum. We want to write out the coordinates of the minimum point. Okay, so if I just pull this in a little bit, and that's a good thing about it, you can manipulate the graph just by dragging it, pulling it in and out. Okay, however you want to do it. Okay, so I know that this is the rough location of my relative minimum. So I need to figure that out. Okay, now on the calculators in class, you got to go in and establish the interval and then let it search for it and find it. But on this, all you really got to do is touch on where you think the relative minimum is, and it gives it to you. So this calculator knows that, hey, he probably wants either the minimum or the y-intercepts or the x-intercepts. So those points automatically pop up for you, and if you want to know their coordinates, all you got to do is touch the point, and it will pull it up for you. So this is a really great calculator to have and use. So especially while we are in the online learning environment, until we get back to regular school, I would suggest you download the Desmos calculator for your phone. Okay? If you don't have a phone or your phone's not working right now, you can also go on the computer and get it as well. It's got a website for the graphing calculators and whatnot. Okay, so what I need to write here is this point. Now, we don't have to take it out to 4 decimal places. I think 2 is sufficient, especially since it doesn't specify. So it's 0.58 is the x value, and negative 0.38 is the y value. That is my relative minimum value. We also need the maximum. And so for the maximum, same thing. You can zoom it back out and bring it over here. There's where my relative max is. Let me tap on the graph. It brings up the points of interest, x-intercept, y-intercept, and the maximum. So all we got to do is, because like I say, this calculator already knows these are probably the points you want to look at. So we just tap on the maximum, and the point comes up. The ordered pair comes up for it. We write it. It's 0.58 and 0.38. And there you go. You got your relative max and your relative min. All right, so you'll be able to take kind of what we've learned here on the notes and apply that to the quiz that is waiting for you in your Canvas course. And I will see you in class.